fourth year. Also principal and director of synthesis design and architecture. His practice, which I'll come back to in a second, but maybe to quickly go through the bio, which is quite notable. Before setting up shop in Los Angeles, Alvin was in London, where right before he moved, he had set up his practice, kind of simultaneously built a profile for himself that he was able to, I think, nicely link practice and all of the efforts he would put forth in the academy, in his case at USC. Prior to setting up his own practice, he was working for Amanda Lovett Architects. He was a director and very instrumental in many of their more celebrated projects, often fulfilling the role of lead designer. Alvin took on that role of director when Amanda set up her own office, which was previously with her partner called Future System, where he was working for a couple of years also as a designer. Alvin and I were almost colleagues. I just learned today that I interviewed there when he was working there. And before Future Systems was working for Zaha Hadid. And again, he was there for quite some time and again took on pretty important roles within the office, designing many projects and 4 or 5 competitions that he worked on. So synthesis, as I mentioned earlier, is Alvin's practice. I think it's one that we could characterize as kind of exemplary version of digital practices. He told me earlier today that he once gave a lecture called Fake It Until You Make It. And I think many offices that were born into that digital practice were doing just that, and very few of them have gone on to really establish themselves as practices that have been able to seamlessly transition a lot of the digital experimentation that occurred in the virtual realm into a kind of material reality. And a lot of his practice today is centered on what he and others call digital craft, where there's a pretty strong emphasis on building a kind of seamless translation between the digital and the physical, allowing that process of fabrication and manufacturing to become a process of craftsmanship, where there's great attention paid to the detail by which those digital projects are manifested. Maybe just a few other things to mention. Alvin has won, as an individual and with his practice, many awards. Perhaps most notable in 2013 was the Volvo Solar Pavilion that he designed and was named one of the 25 best inventions of the year by Time magazine. Alvin's also won a few awards through Architizer and also through the ACSA. He won a new faculty teaching award and has been awarded and a prize for faculty design as well as honorable mention. More recently, Alvin's also been written up in magazines such as Architect, Surface, and Wallpaper. The office was profiled in those magazines. And the Volvo project and competition projects have been very widely disseminated, both in print and in online, probably in many of the blogs that you're all visiting on a daily basis. And I think those are projects he'll talk about tonight. That's all I'll say. Please join me in welcoming Alvin Huang.
Thanks, Kyle, and thank you, Michael, for the invitation. Hang on, I'm going to turn this on here. Okay. It's a great pleasure to be here. It's a little bit cold. When I left LA, it was 90 degrees, so I was in for a little bit of a shock when I got off the plane. But very happy to be here. Share the work with you guys today. The title of the talk today is Coincidence, Incidence, Interference, and it kind of chronicles my interest in technology and my pairing of technology towards design. And I think when we look at a lot of the big advances in architectural history, we can pair a lot of those with advances in technology. From Brunelleschi's invention of perspective as a design technique that is an advancement of a design technology, to Paxton's use of cast iron in the Crystal Palace as a material process, to the implementation of elevators by Otis, and kind of changing the landscape of being able to build vertically. What I'm interested in is both figuratively and literally Moire patterns. Sorry here. So a Moire pattern is a pattern that is based off of taking a base pattern, you overlay that with another pattern, and what the combination of those two patterns produces is what's known as a Moire effect. That Moire effect, what I'm looking at here, is producing kind of three different conditions: coincidence, where they align; incidence, where they intersect; and interference, where they multiply. Multiply meaning the first two produce what I would call additive effects, whereas the third one produces an exponential effect. And this is something I'm interested in a literal sense, but more specifically in a figurative sense. And in a figurative sense, what I'm interested in is the overlay between design research and design practice. And so design research I'm identifying as where we are beginning to explore technology as a technique, and design practice where we begin designing or exploring technology as a tool. But the way we want to view this and what makes these things kind of multiply and exponential is the project lens. So the way you view this sort of relationship and how technology now informs a new design intuition. So what I'm not interested in is thinking of design as a science. I'm not interested in thinking of it as a pure humanity either. I'm very interested in this kind of sensibility and intuition of thinking of design as an intuitive process that is informed by developing a greater sort of agility with these tools, and thinking about the computational tool the same way previous generations have thought of the pen or the physical model, that they're basically tools that help you think. The work that we're working in the office is crossing a number of different scales, from very, very large to very, very small. All of these projects range from academic to self-initiated competitions. We've won some of them have been commissioned, some of them have been realized. All of them are what I would call applied research projects. Those applied research sort of topics are identified as geometric logic, informed form, performative patterning, and digital craft. I'll get into more detail of each of these topics as the talk moves on. Digital craft is something that, as Kyle mentioned, is something I'm really interested in, and less so as a seamless process where we move from digital to or physical as a seamless process, but more in a redefinition of the term craft. And I think the term craft historically has been aligned with the relationship between artifact and maker, and this kind of affinity between the two. And I think now artifact, maker, and process, and I think now that process extends towards a digital realm. So the way we think about making something, there's a lot of sort of feedback in terms of what the process gives the crafter or craftsman. And I think now there's that same sort of feedback where those that are working with digital models understand that there's actually a craft to modeling. There's a craft to producing a tool path. There's a craft towards understanding how to post-produce a 3D model when it comes out, or 3D print when it comes out, or something off the CNC. So we started exploring these on many different projects, but the project that really kind of leapt, or I guess jump-started all of this was this pavilion done in London. It was done with my colleague Alan Dempsey while we were both working at Future Systems. So this is actually a competition that we won while we were working full-time, working on this during our lunch breaks and in the evenings. And was a competition for the AA in London to produce a freestanding pavilion for the 10-year anniversary of the Design Research Lab, which we were alumni from. It was sponsored by a material manufacturer called FiberC, which produces fiber-reinforced concrete. This is how it's manufactured. It's basically thin strands of fiber-reinforced or fiberglass being fed in as a matrix inside of thin sheets of what's essentially plywood concrete, right? Like thin sheets of concrete that are equivalent to plywood. We produced a kind of very quick sketch looking at this kind of continuous form, which moved from all of the different programmatic elements that the pavilion wanted to enclose into one continuous form, and then looked at breaking it up into a series of CNC milled profiles. Each of those profiles is limited by the size of the actual sheet. interlocked into a discontinuous shell structure, which at the time of the competition we proposed would be held together by friction. Everything would kind of bend into position and lock into place. We looked at having a minimum number of 4 connections that would allow them to lock in place together. And we produced a physical model, or a digital model, which after we won the competition went through a huge number of iterations, working very closely with our structural engineers, AKT. What we were producing was these interlocking node models. What they actually wanted was this. They only wanted points and nodes, or nodes and lines. And they were using that to basically do this standalone C# plugin, which would analyze our line node model and size all of the members based off of the forces through that kind of combined network of geometry. And so what you can see here is our model was actually getting really, really thick and really, really deep. Those profiles that we thought we drew as really, really thin and elegant started getting really, really fat to the point that it was unacceptable. So we began working through a number of different refinements and iterations of tapering, skewing, twisting, warping, and trying to manipulate the geometry to get to a workable dimension. In the end, we got the dimension down to something we were happy with. However, we had to implement a dirty little secret, which is this guy right here, 3 continuous steel beams. Basically, the issue was not dead load, it was live load. As we developed the project and we got everything to a workable depth, because of the geometry, it's essentially when the wind hits it, a solid shell. And when the wind hits it from the side, it's racking a lot. And so what we went through a different series of number of options for bracing it. In the end, the most invisible one was to put in these 3 continuous steel arches, paint them gray, and pretend they were concrete and not tell anyone. We also went through this process of trying to develop construction drawings, which we realized traditional plan, section, elevation was not going to illustrate how to put this thing together. So we kind of looked at IKEA flat pack assembly drawings as an inspiration, and we put together an 80-page construction set of assembly instructions. Had all of this reverse packed, ordered, cut, delivered to site, ready so that when we unloaded everything, they would be packed and unloaded in the correct sequence of assembly. We had a script written by our good friend Mark Fornez of The Very Many, which basically intersected all of the profiles in 3D space, sized them based off of the angle of intersection, named them, unrolled them into 2D space, nested them onto sheets, CNC by water jet, delivered to site. When we got to site, we realized, I don't know how Syracuse operates, but I do know that the AA is run by architects, which means it's not administratively not the most organized place. Which means, in this case, we arrived with 800 unique concrete profiles precisely organized into a reverse sequence of construction to realize that we did not have a parking permit. We sent the truck back. The next day, the truck came back. We had a 2-hour window to unpack everything and realized that while the truck was gone, our forklift got stolen. So we ran inside the AA and got every student we could find, and they took those 800 profiles and threw them into about 35 random piles on the side of the site. We then spent the next 2 weeks trying to get a level site with a team of students. After about 2 weeks, we said, fuck it. Let's start building. Put the entire thing together over the course of 4 weeks. Managed to construct everything by our deadline, about 2 o'clock in the morning. The most important document ended up not being that set of construction drawings, but actually this, our 1 to 10 size, 1 to 10 scale physical model, which we coded the pieces, and then the pieces we couldn't see, we put post-it notes. Entire thing was constructed, had a 3-month permit to be on site. It was very, very popular. And extended it for another 3 months, then another 3 months, another 3 months, up to 1 year before we couldn't extend anymore. Ended up selling it in an art auction to an art collector in Singapore. Never heard back from him, so I don't know what he did with it. But what you see here is the opening night, or 2 a.m. opening morning. You can see the construction fence still up. What you don't see is the two steel props, or two wood props here holding up the structure, and myself and my colleague Alan Dempsey and Hanif Kara, our structural engineer, arguing. Hanif argued that this structure was not the same structure he had engineered. Because we had an unlevel site, and because we had thrown all the things into these random piles, and because we were working off of digital files with almost zero tolerance, we had to fudge a little bit to get things to fit. And so there was a couple places we had kicked things in and kind of broke a few pieces to make them fit. And Hanif said it was not the structure he had engineered, and he was not going to risk his engineer's license on that. We argued that we had 12 students climbing this thing like monkeys for 2 weeks. We think it's going to stand. He thought our think it's going to stand was not worth his engineering license. So we decided to keep the two props up, open it for the opening with the gates open. People could wander through. After the opening, we closed the gates, took out the props, did a 3D scan for 1 week to measure the amount of creep. After 1 week, Hanif signed off and said, okay, hasn't moved. I think the deflection had moved, or like maybe something like 4 or 5 millimeters. It was negligible. So we were able to open it up, but we did have to put up this sign. Which, as you guys know, in the US would not be enough, but in the UK, that's enough to say, it's your fault. So this kind of technique also stemmed another project, which was done in London. Again, looking at how you can kind of create three-dimensional form from two-dimensional processes. It was a home office for a private finance guy. I don't exactly know what he does. I know he has a lot more money than I did. And he saw something else I did for another office and asked me to do this installation. He wanted a very sculptural desk in his office, and he wanted to do something that would hide and minimize the clutter of objects in his space. And what he wanted to do, actually, we designed this kind of three-dimensional form and looked at producing it in fiberglass and making molds. And to do it in fiberglass, you're actually making it like 3 times. Like you're making the male mold, the female mold, and then you're actually making the piece itself. So what we actually started doing was looking at, okay, if we do it as two-dimensional cuts and putting together this kind of flat pack assembly of pieces and hanging everything on this kind of dry fit assembly, which hangs on these Z channels, which hangs on the walls. Everything was done off-site. The entire assembly on-site actually took 4 hours. So we basically did everything in the shop. Everything's assembled into prefabricated components. We've got roughly 75% material efficiency here. And delivered to site. Then what you see is inside here we have all of the kind of hidden compartments where his filing and shelving go. There's a few places where there's spaces between the profiles, so you can actually slide filing in that way, as well as feed the paper shredder. Here's the completed thing, and you can see the details of how the kind of spaced out areas bleed into parts where it goes a continuous surface where you have a work area. The guy's a big world traveler, and so we have everything's only fixed at the back where it fits on the Z clips that are holding everything in place. So what we did in the front is we put these horizontal bracers in the pattern of a world map. So he wanted to be able to have this world map, but not have to look at it all the time. So it's a world map when he thinks about it, and it's not when he doesn't. And this is more of the assembly drawings. And that process informed us on another project where we started thinking, well, if we could get 75% efficiency with a geometry which we came up with first, what if we just tried to design around getting 100% efficiency of material? So this table is one which was done for the Beijing Biennale 2 years ago. Unfortunately, we pulled it from the Biennale. We were working with a fabricator in China, and they produced the table. And I won't show you pictures of what they produced because it was really, really bad. But the idea behind the table was that we have this parametric model. Everything is adjustable, so we have the spread of the legs, the height of the table, the torque of the angle. All of those things are kind of nesting inside one another, and depending on how many sheets you specify, it defines how many levels there are, how many overlaps there are. And what we wanted to say is that you have this kind of model that can be given over to somebody who wants to design their own table, adjust the spread of the legs, adjust the height and amplitude, adjust how many sheets. The more sheets you have, the less material efficiency you have. In the end, it was not 100% efficient, but was able to kind of work around this idea of thinking about the way you were going to make it informing the way we designed it. And here you get some of the views into the kind of belly of the desk or table and see how the legs spread. And so this is another project which we just completed very recently. And it's a very different process, but similar in the sense of trying to think about how you're going to make something as the way that you spark the discussion on how you design it. And we got approached by Stratasys to produce a three-dimensional design object for their 3D printers. That was about as much as they said to us. Just give us something beautiful that we can 3D print. And so we went over to Tel Aviv, to Israel, and saw their machine. And they have this amazing, amazing, amazing machine. If I didn't say it yet, it's amazing. It is unlike a traditional 3D printer, which has one head, one nozzle, and prints in layers of say 0.1 millimeters. They have a machine which has two heads. Each head has 96 nozzles, prints in layers of 16 micron, and can print two different materials. One of, say, in our case, opaque cyan, rigid, and the other of white, transparent, soft. And because you can do that, you can do these matrices of gradients between those two conditions. And so what we wanted to do, and one of my pet peeves as somebody who teaches, is that I think students use 3D printers way too liberally. And I see people doing 3D prints of things that really don't deserve to be 3D printed. So we wanted to do something that could only be 3D printed. And so what this chair is, it's a very densely packed mesh using a process called circle packing or sphere packing. We basically derive a shell, pack it with a series of physically informed marbles. Those physically informed marbles are variably scaled based off of kind of giving them physical properties and masses, and kind of aggregate the way that you can think of if you were to put rocks inside this volume. And they define a volume, and then where the heavier marbles fall to the bottom, it gets denser, and where the lighter ones go towards the top, it starts to get more open, and we kind of create this gradient condition that also starts to relate towards ergonomics. So the white areas get soft, the blue areas get rigid, and the rocking chair can have two different positions also as a lounger. And so in the detail here, you can kind of see how that kind of gradient condition kind of scales out towards that perimeter. And the chair is produced actually in a series of gradient steps. So that you basically have to give them 10 files of different gradients, and then they can produce those files. They're now working on one where you can actually color code each mesh vertice, and then you can get a far finer gradient. In our case, we had to do it as these 10 steps. The other topic we're really interested in identifying is performative patterning. In this case, the reference here is a painting by Bridget Riley, who is an op artist from the 60s, British op artist who did these kind of paintings, two-dimensional paintings, which are very three-dimensional and very dynamic. They're always static and they're always two-dimensional, but they always appear to be moving and they always appear to be three-dimensional. And I think that's the way we like to think about the term performative patterns, not as something that is performative, or not exclusively as something that is performative in the engineering sense of being structurally sound or being responsive or doing something with the environment, but actually something that encourages or engages people to visually and physically interact, that somebody actually wants to walk around and engage. Sorry. So this is a project we did in Lampong, Thailand. It is only the facade for a shopping center. The shopping center is on the side of a freeway. So the box we did not design, we only designed the skin. So what we looked at was having this kind of forced Moire pattern where you have this diagrid that kind of reacts and creates hot spots and creates these kind of different densities of opacity. And the way it works is we have a kind of point grid, diagrid, and then a series of radiuses. Those radiuses expand and contract based off of attractor points and attractor curves, and they kind of morph to kind of change a different density of what, there's kind of two grids. There's a pink versus a white, and then they react. At times the white is predominant, at times they're equal, and then other times the pink is predominant. And so what you get is this kind of morphing dynamic condition where we actually wanted this kind of grid to morph to actually say that the signage was not something that was applied to the grid, but it was actually exposed by the grid. That's a battle we lost. The client still maintained that the signage had to go on top. But we were able to kind of continue this idea of keeping this kind of gradient condition in the project. But what started off as entirely free form was thousands of pieces, each unique. We had to look at ways to mass customize. So in this case, we were able to turn it into exactly 5 prefabricated panels. Each of those panels you see mapped out here. But by rotating those same 5 panels, we were able to assemble them into different gradient conditions. What was at first a kind of free-form pattern starts to become a completely linear pattern of gradient. And you can see those 5 patterns here mapped out to the site. Everything is actually entirely handmade. So this is Thailand, so it's far, far cheaper to pay lots and lots of people little money to bend things very accurately than it is to CNC bend. So what we actually had was produced was a series of jigs, and then people actually literally just bent the same number of pieces of aluminum profiles over those things, all attached to a steel structure. And you can see here how you get those kind of gradient pulses from red to white. And then at night, it is all backlit with phase-changing LEDs and produces this kind of gradient condition. And so this same idea is informing this public art installation, which we're doing here or not here, sorry, I'm still thinking I'm in LA. In Los Angeles, it is in South Central Los Angeles at the Slocum station for the metro. And it is basically, we were asked to do, well, it was a competition which we won, to decorate this stair, to do something with that stair. And our idea was basically to say that there is a series of views, one towards downtown Los Angeles, one towards the Watts Towers, one towards the actual bus stop, and to think of all of those 3 views as kind of hot spots. And then what we produced was this installation here, which we're currently in the process of producing the construction documents for. And it's a sort of field condition of what I didn't realize at the time and kind of thought of this as I was giving the presentation. Like, I have to say, when I gave the presentation, when we came up with the design, it's entirely self-absorbed, self-referential. We liked these ideas of producing kind of variable conditions and varying views and kind of something that is visually provocative and you move around and changes and is all driven by these kind of folded petals. And as I was giving the presentation, these public art projects are kind of strange. You're not presenting towards clients. They bring in the community people. And they basically had a black guy, a Chinese guy, a Mexican guy, a gay woman, a lesbian woman, a gay man. It was like a Benetton commercial. And as I was giving the talk, I was like, and this project is about community and about lots of different pieces of different colors and different orientations coming together to create one cohesive thing. And they loved it. So I walked out of that going, wow, I pulled that out of my ass. But in the end, it actually, it worked really, really well. And we got this commission. We're now producing it. But the other thing with public art is that you are not actually being commissioned to design something. You are selling them something. So you get a set fee, and they give you a set budget. And if I sell you something that costs me $2,000 to do, and you have a contract for $100,000, I just made a lot of money. But if I do something that costs more than $100,000, then I just lost some money. So we had this process where we really had to kind of really be very, very, very conscious of cost. And so we began looking at how we can kind of produce these things from very, very limited numbers of means. And so what we came up with was this kind of color wheel of different rotations. And you have exactly 6 colors and exactly 6 different pieces. So those 6 pieces, when they're rotated into different conditions, they're actually the exact, not exact same cut, but very similar cut, all hand cut, but cut. We basically said, let's make the geometry do as little as possible and make the pattern do everything, and the coloration do everything. Everything is kind of hand assembled onto a set of prefabricated steel panels, and then hung onto to cover the stair. And then what we did is we actually sat there and used our parametric grasshopper model and attached it to Microsoft Excel, and basically ran through different pricing options with our fabricators and said, okay, if we have 10 different colors, 12 different colors, 5 different colors, 3 different colors, 2 different colors, front and backside, same color, backside, and all of these different options, and we were getting pricing points on all of these, and also looking what the visual effect is. Because there's actually a certain point where complexity plateaus. Like you get to a certain point and you're paying a lot more, but it actually doesn't look any more complex than the previous one. So in the end, this is what we arrived at. The colors are meant to kind of reference the LA sunsets. I've been told we have the best sunsets in the world. Apparently that's because of the pollution. But we do have some beautiful sunsets. The other issue that I like to talk about a lot is geometric logic, and a lot of this I like to think of as something that deals a lot with a very core issue about delivery for the way my office works, because we have a lot of work that's in Asia, and in Asia we're only allowed to deliver up to design development. And when you deliver up to design development, that means somebody else is producing construction drawings, which means somebody else is absolutely going to change things. And so what we like to do is say we actually dimension things by relationship rather than by dimension. So our drawings oftentimes, instead of saying 35, 35, 35, we'll say equal, equal, equal. So if they change something, it just stays equal, equal, equal. That's what they need to know. Or align, align, tangent, tangent, things like that. So I like to think of the way that I work in Grasshopper very much as the way that I like to describe the work to the people who build it, because I care less about the dimensions and more about the actual relationships. So this is a shopping center. It's a mixed-use project, lifestyle, retail, and entertainment in Bangkok, Thailand. It sits on Planchit Road, which is the main commercial artery of Thailand, or of Bangkok. This is the building that it is an expansion to. It's a 600,000 square meter shopping center, third largest mall in the world, which is 6 million square feet. Our project is 12,000 square meters, so it's like the kind of punctuation on the paragraph. But it's this really, really intense condition, and we wanted to kind of capture that. And this is the site, this is the shopping center, this is the client's headquarters. There's these kind of 2 axes that come through the site, and third one coming out of the shopping center, and creates these kind of 2 nodes. So one of the things we wanted to do was not think of the kind of 2 atriums as nodes, but actually think of them as the kind of shifts of the absence of mass from kind of a series of shifting volumes. And this parametric model actually allowed us to sit down with the client and kind of actually work with them in terms of, again, connecting this to Excel and having a calculation of leasable area versus basically of their area efficiency in terms of what they were getting back on their return versus what our own kind of design whims were, and finding this kind of right balance between this torqued geometry and their return on investment. So once we settled on that, we were able to then begin thinking of this kind of mass and thinking about the kind of skin, and thinking about the skin as something that we really wanted to pick up on the intensities of that urban condition that we were just looking at, and thinking of the interior as this oasis. And we wanted to kind of think of these intensities as kind of carving away and creating these kind of moments of internal calm. And the internal calm, basically the intense areas we mapped as perforated aluminum, something that was hard and kind of glossy and shiny. And these internal areas as CNC milled timber, all wood and kind of soft and much warmer. And it creates these kind of fleshy areas where the wood meets the aluminum. And we have these perforated panels which pick up the kind of intensity of the street lights and lights on Planchet Road. This is the completed building. So you can see here from Planchet Road how you access the building, move through the entries, the kind of CNC milled interior atriums. This one is actually an open air atrium. This one is enclosed. The perforated panels here, and then the kind of tissue of that timber where it meets the perforated panel. Another project which we can't say completed, did, the Guggenheim Helsinki competition. I don't know if anybody in here did it, but we were one of the 1,752, was it? People who entered this. I don't know if anybody saw the Office US study on this, but Office US actually did a calculation where they said if there was 1,752 entries, each entry was done by an office, say there was one principal working on it, 2 assistants, 1 intern for 1 month, then Guggenheim Helsinki just got 15 million euros of free labor. So I'm a small portion of that calculation of free labor. These are our panels for this competition. It was done in we took a little bit longer than the 1 month they specified in that, so we actually contributed more than the 15 million euros. We did it in about 2 months, but basically we're looking at the museum as a kind of lifted social space. So the museum kind of lifts off the ground, and all of the museum is cantilevered, elevating over the site, and we have entirely public on the ground floor, and that public engages the museum up through the central atrium with these kind of 3 views that leak out, but also 3 access points which leak in and torque around this central atrium. And so that torquing actually creates the kind of structural condition and circulation condition where everything torques around 3 cores which support the project, and then these 3 circulation paths which torque around and create those views out. Then we have this kind of big cantilevered truss that is tied back through these tension cables to those structural cores. We did a lot of intense environmental analysis and structural analysis, all done with our colleagues at Arup. Needless to say, we didn't win. The exterior skin has 2 main features. One, they wanted the part of the brief was that they said they wanted to reference Finnish culture and they wanted to use Finnish wood. So one of the things that we did in terms of the wood is we looked at doing these kind of hyperbolic torqued surfaces, but thinking about what we wanted to do as concrete, as permanent formwork. So you would build these permanent formwork structures, pour the concrete in, and then remove the scaffolding and leave the skin of the formwork as the cladding for the concrete. And then what we looked at for the skin was thinking of a traditional Finnish sweater and the kind of variable articulation that you see in that sweater. Instead of thinking of it as something that was articulating the different components of the body, which the sweater does, we're looking at it as articulating the structural condition and different kind of visual conditions of where we wanted porosity and where we didn't want porosity. Another project here that kind of looks at another reference, a very, very different one. This is referencing Claude Parent and Paul Virilio in their treatise, The Architecture of the Oblique, which basically thinks about an architecture that could be continuously walkable, has no vertical surfaces, only oblique and horizontal surfaces, which means that your entire relationship towards the architecture is through gravity. You're either walking up something, across something, or down something. And we began looking at this as something where we could create this continuously walkable surface. We were really interested by the idea of rheotomic surfaces, which was coming from a guy named Daniel Piker in London, who wrote a really, really excellent article on this. But basically thinking about this kind of surface which peels out of the ground. The site connects a park with a residential area, and we create this kind of diagonal condition connecting those two things, pull up these two structural cores, and from those two structural cores start cantilevering and knitting together these surfaces to create this continuously walkable condition where you actually have no designated floor, kind of like a parking structure. You just kind of continuously walk through everything. Because basically what we were thinking is this is a library, and library is actually doesn't make sense, or what we were arguing for didn't make sense to have designated floors. It was a Dewey Decimal System, which was just a continuous decimal system. And it connects through the park, gets this kind of underground condition which moves through. You can see here where the park moves through, and we get these kind of big, massive reading room spaces where, again, because it was all about these kind of manipulations of the ground, we wanted to think of the architecture as something that was not, or the furniture not as something that was added to the architecture, but actually integrative to the architecture. So we began looking at how we can begin integrating by the slope, whether the slope is a ramp, a stair, a bookshelf, seating, desks, etc., and kind of creating these ergonomic landscapes. So that process got us really inspired to think about, it was looking at a process called dynamic mesh relaxation with a plugin called Kangaroo for Grasshopper, which simulates material properties. And this really led us to begin thinking about the work of Fry Otto, who, if you don't know, just passed away a few weeks, or I think it was a week ago, won the Pritzker Prize. He actually won the Pritzker Prize, or it was announced 2 days after his death. The good thing is he was aware of it before he died, and they actually moved the announcement forward to honor him in his passing. But he's amazing design thinker and engineer. And in this case, looking at minimal surfaces and thinking about minimal surfaces as the resultant surface of these soap films that connect two wire boundary conditions. And the minimal surface is actually mathematically defined as a surface with zero mean curvature that is able to connect those conditions. So we began looking at how you can work with dynamic mesh relaxation in a digital realm of beginning to use this process to kind of produce polygonal meshes and relax them to discover known dynamic or known minimal surfaces. So there's actually a catalog. If you were to Google minimal surface, there's a catalog of known minimal surfaces that exists. And all of them can be created with algorithms and kind of computational methods. I'm not a programmer, nor am I a mathematician. And even though I'm Asian, not that good at math. So I'm far more interested in the intuitive process of trying to understand how to reconstruct these things. And so we were really trying to say, okay, how do we develop an intuition about how to produce a minimal surface? And so we basically challenged ourselves with these exercises to reverse engineer and reconstruct known minimal surfaces and then analyze them to try to understand how they were performing. And we found the perfect opportunity to apply that with this competition. So this competition was for Volvo. It was to produce a structure for this, which is the Volvo V60 plug-in hybrid electric car, which had just been released. And it was basically a competition which was open, had 200-something submissions. We were one of the 10 finalists. And as you can see, pretty much everybody did what the brief asked, which is an iconic structure that could be portable and showcase the car. But what everybody did was basically produce essentially a kind of, how should I say it, a prefabricated garage. And what we wanted to do was think of the pavilion not as a garage, which is a destination, but as an accessory, so something that you could bring with the car. And so our two goals that we set for ourselves was, number one, we want to say that the pavilion is transported by the car, so we had to make sure it could fit and flat pack inside the car. Number two, we said it's an electric car. We want the pavilion to charge the car. So this process, I'll let this video play here.
In spring of 2013, Volvo Italia and the Plan magazine launched the Switch to Pure Volvo Open Architecture Contest to showcase the new Volvo V60 plug-in diesel hybrid at undercover trade shows and open-air venues in Italy's public squares. Attracting over 150 entries from around the world, the winning entry was the Pure Tension Pavilion by Synthesis Design and Architecture. The entire pavilion assembles and demounts in less than 1 hour and fits in the trunk of the car.
The Switch to Pure Volvo competition organized by the Plan and behalf of Volvo was interesting to us in terms of the kind of questions and challenges that it raised.
They required that the structure is something that was easily assemblable, easily dismountable, and could travel with the car, and was an iconic structure that could really showcase the car. We saw this as the perfect opportunity to apply some of the research we've been doing into dynamic mesh relaxation and thinking about how we can look at fabric structure in terms of thinking of something that's lightweight, portable, and easily collapsible. So the original idea of this was that the structure would wrap up and bundle into like a little package, like a laundry hamper, and just kind of pop open, which would have put us well out of budget. So we ended up moving towards a CNC bent aluminum frame, so it is slightly outside of the final shape it's going to take, but it gets tensioned into position by the skin.
On my spare time, I like to go backpacking, camping. So a lot of the stretch fabric aspects of it was something that actually was very attractive to me because it's something I was so familiar with, that lightness and efficiency. And also the elegance that the combination of the simplicity and sophistication conveys.
We took that a step further and began thinking about it as a charging station for the car.
We wanted it to actually be integrated into the whole structure. That it's not just a plug-in interface with the power, but it actually produces its own power.
So when we saw this design, obviously, there were a lot of things that we saw that fit together.
After the winning of the competition, we went through a process of rationalizing the geometry to make it more buildable. Worked very closely with our structural engineers, Bureau Happelt, which are based here in Los Angeles and Culver City. And then we started working with Fabric Images, who are based in Chicago.
The design idea behind it is this idea of pure tension. We weren't sure how we were going to do it, but we started. And we started figuring out what worked and what didn't.
Where we're at right now with the frame is that we have through bolt connections. The next step is to drill out and countersink all the connections for sex bolts, so it needs flush connection, so there'll be nothing protruding.
And eventually, between the seamstresses, between our CAD guys, between myself, we figured out how to do it.
Ascent Solar provides us with these, which are flexible photovoltaic panels. So unlike normal photovoltaic panels, which are extremely rigid and extremely heavy, these are extremely light and flexible.
Because of that constraint, we had to choose a lightweight, 70% open mesh. And what's interesting about mesh relaxation techniques is they use the natural qualities of the material to create a shape. What's interesting about this structure is it takes the natural qualities of the Volvo and lets that inform the formal qualities of the structure itself.
The entire pavilion, in terms of the skin, fits into a small box, whereas the perimeter frame, because it is a kind of slip-fit tube, like a tent, T-mounts and will fit into the trunk of the Volvo.
There is a positive side in that it will provide solar energy, but there's a negative side in that it heats the car. And just cooling the car to a comfortable temperature requires a lot of energy. So anything that could reduce the solar heating of the car while also providing the electricity that the car wants is a win-win situation. And also to do it in such an efficient way and in such a beautiful way, that is, was something that our innovation team always looks for, and it was great that, even though we had not found it ourselves, that we could support the innovation process that could enhance our products and hopefully enhance the world at large.
The interrelationship of our structure and the car is something that kind of drew attention to the car and also allowed you to experience the car in a new way. I think what's really surprised me in this journey of producing this pavilion and winning this competition has been just how forward-thinking Volvo has been in terms of engaging us as designers and giving us the freedom to do what we're interested in and really pushing the limits of what our fabricators are able to do. And they've been very supportive of that and engaged with us in the entire design process in terms of producing something that we think is really an amazing concept that we hope can be applied towards future products and future opportunities.
So the geometry is basically based off of a 3-point system. There's 3 modes to the car, so part of the spiel in terms of identifying this as something that was relevant towards Volvo was that it referenced the 3 modes of the car. There's a power, pure electric, hybrid, and a pure gas version or mode. So we basically have this 3-point surface, three entry points, 3 legs on the ground, 3 legs up in the air. We went through a series of tests to kind of test the different patterns and physical prototypes versus a lot of structural analysis by Bureau Happold. Bureau Happold is working, this part's actually really important. Going back to the whole geometric issue and fabrication issue, when we first did the bid for this, the bid was way outside of our budget to do the CNC bending for the perimeter frame. And I'd never done CNC bending before, and so I was really curious, and I was like, okay, why does this cost so much? I didn't realize this process cost so much. And it turns out that the way the CNC bending works is they charge you per radius. And our radius, our freeform geometry was like thousands of radii. I said, so if I can turn that into 5 radii, what will it be? And so it was a lot cheaper. So we turned it to 5, remeshed everything, got it within budget. Structural analysis was done by Bureau Happold. We were using Kangaroo, which is free. Plug-in for Grasshopper, which is free. Plug-in for Rhino, which we have a cracked version, so it's free. And they are using a software program called NDN Membrane, which is $40,000 a license. And our structural analysis, or our form finding versus their form finding, had a 2% differential. Again, pretty good for something that's free, but I would not bet my life on that 2%. I think it's pretty critical that the engineers are involved, that they are able to sign off on that. But I do think it's pretty cool that you can use something that is entirely free and get to within, through a purely intuitive process, not an engineer, not trying to engineer it, just trying to understand how it works and how to design with it. You can get within 2% of an engineered result. We have, at the time of the competition, we had this kind of gradient pattern of flexible photovoltaics, which was purely an aesthetic whim. We were just interested in expressing the gradient. So what we did after we won the competition is we knew it was going to be touring Italy. We did not know where it was going to go. We did not know what time of year it was going to go. We did not know what orientation it was going to go. So what we did is we analyzed the pavilion for 365 days of the year, 8 hours of the day, for 360 degrees of rotation, to find the areas of greatest solar incidence, and created this kind of heat map. That heat map gets then remapped towards a grasshopper definition, which creates a sort of graphic pattern, which is a very kind of stylized version of that map. And based off of the kind of cells that are driven there, we begin to map where the photovoltaics go. That whole thing gets unrolled into 2D space, put together as these developable strips, and then manufactured and stitched together. The last thing is that photovoltaics have a weird property, which is they're only as strong as their weakest link, which means at 6 o'clock in the morning, the weakest link is everything other than those pink cells. So what we were able to do with the help of our solar consultants was implement something that's called a MPPT, Maximum Power Point Transmission Controller, which basically does a real-time sensing of the solar array. And as it's sensing, it disables anything that does not fall within a certain threshold. So the pink ones are the only ones that are operating at all times. So you're always able to get the maximum charge you can get to the pavilion. So the whole thing basically flat packs in about 1 hour to assemble, charges the car in 8 to 12 hours depending on the amount of sun that's available. Obviously, you will never have 12 hours of sun unless you're in Norway. So what we are seeing it as is something that you could leave out, charge, and leave the battery there, come back and collect it. So it's all cut here in a Zune cutter, which is a 2D cutter, stitched together. You can see here the pattern. CNC pipe bending. All of this fits inside a B case, which is a 60 by 15 by 15 inch box. I like to call it a coffin for a small midget. Assembles. This was our first time putting it together. It took 3 of us who had never done it before 45 minutes. Sadly, now that we've had lots and lots of time to do it, we still do it in 45 minutes. I don't know why. The entire thing has, it's won a number of awards, traveled the world. We were not able at the time to meet our deadline and solve this detail, which is the seams. So the seams were supposed to go inside, or the wiring was supposed to go inside the seams. And the panels were supposed to be the same shape as the leaves. We are now working with our fabricators, and we've developed a process that we can get the panels the exact same size as the leaf, and all of the wiring is embedded in the seams. So we're now working on producing this as a limited edition production item, only available in China, because only people in China are willing to pay for it. This is the pavilion. I'm going to end with 2 slides. This is a quote from Mark Weiser, the godfather of ubiquitous computing. The first talk I ever gave was at a conference called Digital Architecture, and I liked to end with this quote because this image is of what was then known as the horseless carriage. Fast forward 100-something years now, and we call it a car, and nobody cares that there was a horse. And right now, a lot of people are talking about, or have been for the past 20 years, talking about digital architecture. I don't think it's digital architecture. I think it's still architecture. And I think it is very much, this is a quote from Neil Denari, who really inspires me. And this is the way I like to think about it. Like, in the end, you know, what I'm into is really making things and really just kind of the pleasure of making things and the pleasure of physical artifacts and knowing that, you know, good design can change the world. Thank you.
Thank you, Alvin. Alvin will take questions. There are any. Yeah.
Hi, my name is Charlotte. I was just wondering, like, how much you actually utilize the Grasshopper, because I know that the very many that use Python scripting. I was just wondering if you actually utilize it.
We don't do any scripting. When we need scripting help, we ask Mark. So the very many, I'm good friends with Mark. I went to the AA with him. I was there when he learned to script. I don't know, I can read script, but I can't do it. It's useful, but it's not what I'm interested in. Like, I'm a visual guy. I need to be able to see the stuff. And that's what I like about Grasshopper, is as much as it is now pervasive and kind of played out, like, I like to think of, I'm essentially creating geometric diagrams for my project by doing a Grasshopper definition.
Thanks so much. Thanks so much for the talk. I had a question about the investigation into materials and processes and possibilities with materials on the one hand, and the situation of the project on the other. So there are some projects like the Helsinki project, which seem to be driven, and I know it's a markedly different scale, that seem to be driven by some, we'll say, social concerns, and other projects that seem to be sort of obsessed by manufacturing process, and how you work between those two issues.
I would say that the social concerns are something that I will openly admit are coming in later into my stream of thought. I have actually been, I actually recently gave a talk at Morphosis. Like Tom Main invited me to give a talk there, and he actually, it was one of the best discussions I had after a talk, and he spent some time with me, and he's like, you know, it took him, his exact words, I'm paraphrasing, but his exact words is, it took him a very, very long time to find his own formal language. And his biggest criticism to me was that I seem to have found the formal language early, but I have not found the social agenda for the work. And it is something that I'm still looking for. And as a more recent project, the Helsinki one, we put more effort into thinking about that. Or I will be very honest in saying previously, I was only interested in making something and pushing a different agenda. And it is something that I'm, like when he said that to me, it made me really think a lot about myself and about the work. And hopefully the work is still evolving towards that. But I would say the earlier within the stream of work, the less we're thinking about that and hoping to incorporate more of that as we move forward.
Are there others? I have a question, Alvin.
Yeah.
This goes back to something we were talking about earlier today, mostly related to the kind of access and ease of expertise with a lot of the digital technologies that you're employing, and we talked about how as that moves into practice, it moves more towards the scientific and becomes less concerned with aesthetics. And of course, that's not something you're leaving behind. I guess I'm just wondering to what extent those push on each other. So to what extent does the qualitative push on the quantitative, or the things that are a bit considered more through the lens of atmospheres or kind of visual sensations push against things that are more quantifiable and scientific, and vice versa?
I mean, I would say ours are, when we're thinking quantifiable and scientific, it is usually almost exclusively within the realm of buildability. Like it's actually just, can we achieve what we want to achieve aesthetically and formally within the budget and be able to deliver it? And that's where the quantitative aspect starts coming in for us. Other than the little bit where we did with the solar analysis, where it really was actually, okay, we sold it as something that could charge the car. It should probably do that. But I think it is something like I have very mixed sentiments about, because I do feel very firmly that I don't want to pursue design as a science, and I don't want to think of design as a qualitative exercise. And I think most of the generative computational, I'll say all of the generative computational projects I've ever seen are actually not truly doing the things that they're saying they're doing. They're actually highly curated manual manipulations of computational processes to achieve a desired aesthetic that you sell as it created the optimum surface and structure that did this or whatever. And I would much rather be honest about what I'm interested in expressing and trying to say, well, I want something that looks like this and feels like that and does this. And I was recently, Ken call it reading, going through Jimenez Lai's Citizens of No Place, and there's a chapter called On Subjectivity. And it talks about how architects should be less concerned with qualitative analysis of their projects and more statements, I like it, and more important, I like it because. And I think that's also something that I'm trying to have this balance between using the qualitative things to be able to deliver, and the quantitative to deliver, qualitative to drive my own sort of, or my office's own intuitive explorations of form. Because I think form is something that has in many ways and like become almost a bad word for a while. Formal projects are kind of labeled excessive, and kind of, I think as architects, we should be very, very much in charge of form and be very, very much proud of that.
Are there any last questions? Okay, thank you, Alvin.
Thank you.